Live on Twitch. Recording in process. Okay. Nice. Your screen share is loading. You're sharing screen. Message. Oh, that. Friend request. Please. All right. Fun. Anybody have any questions on any of the exams? A lot of time.
I had a question about power. On exam one versus exam two. On exam one, what is it, 1D? You don't divide by half. But on exam two, 1C, you do divide by half. What's the difference?
The difference is on exam 2D, it looks something like this. It looks something like this. You have heights. Someone you have something like this. So mother brother. Look. You have man, that's very delayed. You have these things, hopefully you got these values from your Bessel table. 1.15, 4.4, 7.65, 4.4, and 1.15. And the frequencies were 100 hertz. You had 110 here, 120, 190, and 80. So these values right here are actually single-sided spectrum. So if we were to write it down in a double-sided spectrum, double-sided, it would have been like, it would have been two sets of lines like that, and this would have been the negative 100 frequency. Negative 100 frequency, this would have been the 100th frequency.
Yeah.
And this is where you would divide, where you wouldn't divide by 2. Because both of them are here. Right? This one right here includes both of these. You know what I mean?
The single.
Yeah, the single-sided spectrum includes both of these values here. So we have to divide by 2. Yeah.
Is it? I mean, 1C says it's a double.
1C. Yeah, 1C is double-sided spectrum. Let me see. That's the first exam. So notice there's a negative side and a positive side for the spectrum. So in that case, you didn't need to divide by 2.
So if it's double, it's not divided by 2.
Right.
Okay. Gotcha.
I guess for the Bessel tables, you gotta divide by 2. And when you think about it a little bit, when you get the power, that's 50 watts. That comes from 1/2 of the 10 squared. If you recall, it's a sinusoidal. It was 10 cosine. What is it?
That's it.
XCT. Okay. How do I move to another page? If you remember XCT, god dang it, I don't have a glove like those fancy ones. If you recall XCT and the problem was given as 10 sine of 200 pi t. If you look at this amplitude right here. And you get, and you square it, and because it's a sinusoidal, it gets only 1/2. That's where you get 50 watts from. That's where you get 50 watts hour. Okay? If it had been a triangle wave, it would have been a third. And if it had been a square wave, it would have been a full, right? So when you get 50 watts here, and for some reason, you get 100 watts over here, that means you probably get something wrong, and you need to divide by 2. You know what I mean?
So single divided by 2, double.
And so when you calculate the power from the function itself, you get 50, and over here you get 100, you're probably gonna have to divide by 2. Cool. Good question, keep them coming.
Brenda, do you have the quizzes on you?
Right?
Do you have the quizzes on you?
No, but I could probably pull them up. Wait, no. Have you ever turned them on?
Have some of them, but all of them.
What's the question?
Quiz 3, problem F, 1F.
You take a picture, send it to me, or send it to the group chat?
Okay.
That'll work.
Which one?
Quiz 3. You know, I'm just gonna wing it. Good luck, Corinne. You just need to give me a C and I'll be okay.
Wait, with that 30-point curve, maybe, yeah, I
Huh?
think we'll be all right.
Yeah, I'm saying.
30-point curve.
Oh, yeah. An exponential rise.
All right, you said 1E? Or F?
F.
Oh. I don't remember. No, the total set amplitude of this spectrum of modulated outputs. MT cosine minus MT sine of 20.
Which one?
Ah.
Quiz 3, 1 up.
Oh,
That's the dumb.
Okay,
Look at that.
okay.
wow. I think. Can't believe he gave me 9 out of 10.
No, he went over it, but
Oh, that's many questions.
Yeah,
Are you?
Yeah.
let me just get my handy dandy
Right or wrong?
formula sheet real quick, and I'm gonna need it.
This.
What's this? This is my formula sheet. Yeah, fun quiz too.
You quiz 3, I have it right here.
No,
Read it. I have
no,
it.
I was just looking for my formula sheet that I wrote a while ago. I'm gonna need that for the exam.
How much is the percentage on the unitary?
It's M,
5.
or no, like,
40%.
No, you said 50 by the end of it.
Ain't no way.
You did it.
I guess, cause.
so
It's your personal
we go over the entire thing. Let me draw out the image at the top. It says there's an audio message coming in. Audio, come on, work with me, audio going in. It's gonna be split up into two sections. One is gonna be the Hilbert transform. And the other one's gonna be normally. Gonna go into a product here. This is gonna be the carrier. And then. There's gonna be a sine wave, it's gonna be a cosine wave. And then. It's gonna add the product here and it's gonna subtract it from here. And this is the outputs. Okay. So. Your message signal is. 4 sine. 2 pi t. It's a very boring signal. So that's what's gonna go into here. That's what's going in here. Over here, however, there's gonna be something called M prime T or something like that. I believe. No, M hat T, sorry. M hat T. That means that we're gonna apply the Hilbert transformation to this signal right here. And the Hilbert transformation, if you recall, all it is, let me find it. I didn't write it down. Oh, here it is. It's the same as the normal message signal, however, you have to subtract. Oh. Damn it. Oh, it's still there.
Just like so.
Hope it all saved. Wait, what's this? Okay. Whew. It's the same thing here, however, you have to subtract 90-degree mother club.
Stop sharing.
Oh, yeah, sorry about that. Okay. So it's the same thing, except you subtract 90 degrees. So. This right here is the normal signal. Over here, it's the same signal, but shifted 90 degrees. Okay? Now you have to multiply the cosine to this signal. And multiply the sine carrier signal to this signal, all right? That's where the problem comes in. It says MT times cosine of 20 pi t minus m hat t sine of 20 pi t. That makes sense? You see what's going on? Liz?
Yeah.
Okay. So our message signal right here, it's 4 sine of 2 pi t times cosine of 20 pi t minus 4 sine of 2 pi t minus 90 degrees times sine of 20 pi t. That's it. Solve, and that's the answer. How would I solve this?
What is this for? 1E?
I think so.
Well, no.
1F, yeah, sorry, yeah, 1F.
Oh, what?
This will get you the outputs of the modulator thingamajig. Pretty cool, right? What's this here, Amanda? Hello, Amanda.
Wait, I thought we needed to draw the double-sided amplitude and phase spectrum for that.
Oh, we do, ugh, I guess,
You just
Well-
work all out and,
huh? Let's do it then, fuck it. Sine, to make it cosine, you have to subtract, right? We get
-5/2.
minus power two, for sure. 4 cosine of 2 pi t minus pi/2 times cosine of 20 pi t minus 4 cosine of 2 pi t, but this one is gonna be minus pi, right? Times cosine of 20 pi t minus pi/2. And I know I'm using degrees and radians all over the place, but we're smart, we get it, right? So cosine product, the formula is 1/2. The amplitude is 4. Cosine of their sums, which in this case is 22 pi t minus pi/2. Plus their differences, which is cosine of -18 pi t minus pi/2. That's the first one, minus 1/2, the force of amplitude. The cosine of sums, which is 22 pi t. The sums minus 3 pi/2. All right. It is. Shit. Plus the cosine of the differences, which is -18 pi t plus pi/2. I believe. Anybody see any mistakes? I know I never make mistakes, but I could be testing you guys. What the fuck is that? So this is a 2. Cosine of 22 pi t minus pi/2. Plus 2 cosine of -18 pi t minus pi/2. Minus 2 cosine 22 pi t minus 3 pi/2. Plus, hold on, this is a negative. Because the negative here distributes. Minus cosine of -18 pi t plus pi/2. Combine like terms, I don't see any like terms. No. No like terms. All right, so now we have 4 different signals. Not 2 of them we're gonna cancel, but I guess not. I'll check my work with decimals later. We turn it into exponential form. This one becomes e to the j 22 pi t minus pi/2 plus e to the negative 22 pi t minus pi/2. However, there's a parentheses there, so this becomes, oh, we'll listen later. That's just the first one. Eddie, how's it going? I never doubted you were gonna come.
Still.
Plus e to the
Make
j
it that complicated shit.
negative 18 pi t minus pi over 2 plus e to the negative j negative 18 pi t minus pi over 2. God damn,
Are you sure you didn't mess up?
I think I didn't. Why would I mess up? I thought two of them were gonna cancel. When did this become 90 again? Or 5? Oh. From sine to cosine. It's the sine wave. The cosine wave. Right. You have sine and theta. Cosine. That's one to the right, which is minus pi over 2. It's minus pi over 2. But if we already have a 90 there, then it becomes minus pi, yeah.
Negative 90 minus 90, negative 183.
Yeah, that's what we get this pi. Yeah. Wish I had my quiz, I'll do it once. Um. Um. ¿Cuánto anyway? My kids were asking about you, Eddie. My kids were asking about you. Kids? Yeah, my bus.
Why you do this?
They were like, oh, sir, are you still working with that guy that doesn't wake you up? And I was like, yeah.
They had some conversation with them finding out that I wake up.
It's just one time you told me to wake you up and I was like, bet. So,
She's just like stupid, but.
So-
Well, hold on.
no, even better, even better. I told my kids to wake him up. I was like, here, I'm calling Eddie, tell him to wake his ass up, please.
And he didn't answer.
He didn't.
If you did, you would have
You wake up.
I would have been fucking scared with the this.
abducted, and
Why are your kids telling you to wake up?
satanic old kids just took him and his phone and called him.
That would have been scary to wake me. That would have been a nightmare.
So you would have gone like this.
Probably. I would probably.
You would have been happy because it would have been your excuse.
Yeah.
Not today.
Not today.
It's right, isn't it?
As Nicole was doing.
Trying to do math. Press.
I mean, I think it's right. You know what, let me just ask Desmos.
Yeah, come on, man. Using resources.
Yeah, no time to waste here, we're slow.
It's a couple with a hump.
Desmos.
Yeah, they go rich.
Que todos salgan bien sus.
Hey, we put on here.
Let's learn together. Wait, no, it's a graphic factory, I mean, symbol lab. Okay. So the question was. For, can't see. 4 sine of 2 pi t times cosine of 25 t minus 4 sine of 2 times 5t minus 5. Wait, no, 90. Out. Times sine of 25. Which is gonna give you the same expression back, wasn't it? Other. We are using trig identities.
Put on the sign.
Sine cosine, I turned this one to cosine. Stupid. That's one way to do it. Okay, so something did happen wrong. And. Cosine. Cosine. Use so much easier on the board. Um,
Do we have you stamped, Rene?
little.
A little. I have a feeling he's gonna throw us one of his quizzes questions.
Well, I mean, this is the way to do it. I just can't get it to,
Cancel out
yeah.
20,
Why are you trying to get?
20.
Because it's gonna cancel out. Well, there's a 2 here. Look at that 2. Not that it helps. Cosine minus 5.
Did you do plus or minus first? What is it?
I always do plus first.
Plus.
Well, doesn't the negative 18 one cancel out then?
Which one? These two?
Just plus the other one's negative, right?
Why is it plus power two?
Because it's
Because it is negative pi.
pi t minus pi minus 25 t minus 2. So this minus negative is positive, so it becomes positive pi. No, negative pi 2. Yeah, you're right. Who's that? That's 1 canceled. So these cancel here. That works. Get rid of those. And then this one. Minus 2 cosine 22 pi t minus 2. Well. Answer here, it's supposed to be a single sine. This is. That we should be having a 22 80, so. Awesome. Oh, how can I do this?
You know, for the -2 cosine,
Yeah,
the -3 pi/2, how I did that was that's already a pi, so it flips the cosine, so it becomes +2 cosine 22 pi t minus pi/2.
yes, yeah, if we look at the unit circle. -3 pi/2 is right here. But the same thing as 990. This is the same thing as -2 cosine of 22 pi t plus pi/2.
Listen up, I speak.
Um. Didn't cancel. Shouldn't cancel, we have to be left with something. Hmm. Cosine.
Couldn't take out a pi and make it a positive though?
Mm, Taking out pi.
Because it's the phase, right? So it'll shift it.
Yes.
So then it goes from the -2 cosine to a +2 cosine.
Answers. 4. Well,
Or is that last one supposed to be also -3 pi/2?
okay. There is an identity. That says negative cosine. Is equal to cosine, right? No, wait. No. No, that's. The identity is. Cosine of negative theta is equal to cosine of theta. Right? I don't know if that's gonna. Because there's no.
Can you put it in a graphing calculator to see if they're the same?
So. No, Desmos. It's -2 cosine of 22 pi t plus -3 pi/2. It's 1. And oh. 15. And then you want to see if f of t2 is equal to 2 cosine?
Yes, minus pi/2.
Oh, shit. Well, feed me garbage and call me munchlax. They're the same.
Yeah, because it's 3 pi/2, that means it's a pi, like -pi minus pi/2. So that pi just flips the signal.
Oh, I see what you mean.
Yeah, so it goes from the negative to the positive. And that's how you can do, you add them together and you get 4 cosine 22 pi t minus pi over 2.
Damn. Right.
John Random,
Huh?
the John Random.
Yeah. So this happens to be the same thing as 2 cosine of 22 pi t minus pi over 2. And then you add them both up, they become 4 cosine of
Yeah.
22 pi t minus pi over 2. Which is 2e to the j 22 pi t plus 2e to the negative j 22 pi t. I forgot the base. This negative distributes, don't forget. So the amplitudes are at negative 11 hertz and at positive 11 hertz. Amplitude is 2. And the phase is at positive 11 hertz, it's gonna be negative pi over 2. And at negative 11 hertz, it's gonna be positive pi over 2. Damn. Woo! Yes, oh, you want me to move it up? Sorry. I'll be sharing this with you guys once we're done. I'll post it on Blackboard for you guys. Oh, wait, let me know when you're all ready.
Was this from the quiz or from the test review?
It's from quiz 3.
Oh, okay. I was confused. I was like, that's not what I got for the test. Okay, thanks for letting me know.
Yeah. You know what happened to my quiz? Oh, I wasn't here for quiz 3.
Really?
I think I knocked the fuck out. I was sick.
Say, I don't wait.
I had your presentation room.
It's alright. The professors laughed at us, remember?
Yeah.
They laughed at us when they suggested we wanted to put solar panels on the person. Those professors in Brownsville were mean.
They're mean.
Zoe and I'm the other ones.
Brownsville?
Yeah. That's where
Why?
that's where me and Eddie took senior design. Soto was cool, but then Zoe and the other one were like asking the difficult questions.
Constant questions too.
Zoe always asks difficult questions.
Well, now I know.
Are you coming back to Edinburgh?
Yeah, this next senior design is gonna be more within my schedule. Any more questions?
Can you do us a huge favor?
Yeah, what's up?
Convert your test 2 in a PDF and send it to us?
Sure. Might have to do that at home though. Unless someone wants to take pictures of it real quick.
Scan it?
Not sure.
Or if anyone there can scan it, that
Yeah,
would be great.
Mr. Fuck, And Miller, Mr. Miller is the.
You know about the autocorrelation problem?
Autocorrelation. I don't. I wrote some stuff down, but the way he was talking about it didn't make sense.
Speed running it.
You go over,
We must be doing
can you go over quiz 2?
I can go to quiz too. What does I find
You don't have it?
it? I have it, I saw it, but so I pull it out. Homework to.
Quiz 2.
Look, homework. Oops. Where am I, you know? Okay. Capstone design experience. Quiz 2. All right. Put a new page.
Also, your solution for quiz 3, San gave us a different solution for that one.
What do you
He gave us amplitude of 2 and 0 and a phase of 180 and 0.
He's wrong. An amplitude of, it was at 11 hertz, right?
I believe so.
11 and 11. Because they have to be symmetrical. They
Yeah,
can't-
it's at 11 and 11.
Right, and they're both amplitude of 2.
No, only one is amplitude of 2, which is negative 11, and then positive 11 has an amplitude of 0.
Well, that breaks his own rules, because he says that they have to be symmetrical about the 0.
I
Right?
don't know.
Anybody remember that?
I think he was going over something else when he gave us something like that.
Hmm. And
I
then
think he was just adding stuff up and telling us what it should look like or something like that.
when the amplitudes always have to be symmetrical about the 0 vertical line here. And the phases always have to be symmetrical about the origin. So like they can be like that. But they have to be symmetrical. I forgot the word for it. It's a word. Contrast symmetrical? I don't know. But like they're flip-flopped. So one of them cannot be 0. It's just doesn't make sense. Anyway, I'm right, sounds wrong. Don't tell him I said it. Using the differentiation theorem, find the Fourier transform of this. Xt is equal to -2 triangle function t minus 1. All right. So it's gonna look something like this, right? It's gonna be like something like that. Maybe not exactly there. There's that. Anyway, it's gonna start at. The triangle is defined between -1, t, and 1, right? So if we have t minus 1, it's gonna be, t is gonna be defined between 2 and 0, right? So we draw this, we draw 0 here, we draw 2. Okay. The amplitude is 2, and it's a negative, so it's gonna look like this. Right? Make sense?
Makes waves.
Hmm?
Makes waves.
It makes waves, indeed. . Pretty cool, huh? All right, so the differentiation theorem. We could have just find the Fourier transform of a triangle, but he doesn't want us to do that. He wants us to use the differentiation theorem. So we have to find the differentiation, the derivative of x of t. Okay. So we're gonna draw a new table, new chart, Cartesian plane. And from 0 to 1, what is the slope? From 0 to 1. The slope is rise over run. It rises -2 and it runs 1. So the slope is 2. Yes, no,
Yes.
2. From 1 to 2. From 1 to 2, the rise over run is 2 over 1, right? So the next is gonna be, oh shit. Sorry. It's negative. It's like this. And then on this part right here, let's do it in another color. Yay. Oh, sparkle. Maybe not sparkle, you guys. Let's put rainbow. This part right here is gonna be +2 because this slope right here is +2, this slope right here is negative.
He's mad that they chose that color.
Does that make sense? So this is our base for our base function. This is our first derivative. Now we need to find our third derivative because it still doesn't look like pulses. We draw it again. The slope at 0 is infinity. Right, it's undefined, it's infinity. That's for mathematics. For engineers, the slope at 0 is -infinity with an amplitude of 2, -2. Right? Then it's 0. From 0 to 1, it's 0. Right, 0. And then from 1, it jumps 4 units up. It becomes undefined with an amplitude of 4, right? It's infinity, but it's like super fast speed of 4. And then 0 again. Until 2. And that becomes another -2. Do you see it? You see how this, the derivative became this, and then the derivative of that became this?
Yeah.
Okay. Now we have our pulses, finally. This is d squared over dt squared of xt. Yes. So now we look at our table for the differentiation theorem. It states d to the n over dt to the n of xt is equal to j2 pi f to the n xf. If you don't find it, find it later. It's under the Fourier transform theorems. Differentiation theorem, it's the second to last one. So here we have our xt in terms of time, and here we have our xf in terms of frequency. We know that the second derivative of our xt is gonna be equal to this little constant here squared times xf. So now all we gotta do is take this right here, divide it on both sides, we're left with d over dt squared xt over j2. That equals xf. We can't leave it like that, we have to figure out what this is. So we have our pulses here. This pulse right here is at 0, and it's -2 delta t, right? And then we have another pulse at 1 with an amplitude of 4, so it's 4 delta t minus 1. And we have another pulse at 2 with an amplitude 2 at t minus 2. Do you see it? This right here is this. So the second derivative of our xf is equal to this. 3 pulses with 3 different amplitudes at different times. Make sense? So now all we gotta do is write it down again. 2 t plus 4 t minus 1 minus 2 t minus 2 all over j2 pi f squared is equal to xf. Boom. That's the answer. Easy peasy. Now, if you were to simplify it, if you were loaded, this would eventually become, I believe, the sinc function. But ain't nobody got time for that.
Right, I just saw a video.
Ain't nobody got time for that. No. Distractions. Make sense? Plus. Put a rainbow box around it. Whee. Well, don't scoff at rainbows. And I ran, your shoes were that G. I ran from my life. Oh, you didn't even watch the remix?
Yeah, I'm not. It's just the original video.
Can you still see me? Yeah, hi. There's 6 people here, 5 people here.
It could have been 6. Yeah,
So 3, 4, 5, 6. It is 6.
could have been 7.
I could have been 7.
Come on.
All right. Let's continue. Evaluate using Parseval's theorem. Fine.
Well, I think it's part of the world. Why do you want to do it?
Parseval's theorem states. Well, let's write down the question first. X is equal to -infinity to +infinity of sinc squared 4f df. we should not differentiate, integrate in the frequency domain. We cannot do that. We cannot. So Parseval theorem states, did I write it down here? I didn't. Crap, I don't want to write it down incorrectly. Oh, here it is. I did write it down. The integration of xf squared df is equal to integration of xt squared dt. Ah! dt. Move, Liz. So if you're gonna integrate in the frequency domain, you better change it to the time domain first, and the integrations will be the same. Don't forget that you have to have the squared there. Now, we want this bad boy right here to look like this. How do we do that? Well, it's already squared. That's helpful. We have our sinc squared of 4f here. No yawning. We can bring this squared outside like that. So now all we gotta do is make this equal to sinc this right? Yes.
What happened to the sinc squared?
Hold on, the squared is right here.
Why?
Because let's say the cosine of x, cosine squared of x is the same thing as cosine of x. Quantity squared. There we go. Same with all trigonometric functions. So now we have our xf. This is our xf. Okay, so xf is equal to sinc 4f. Boom. Now we need to find our xt. What's xt? We go to our Fourier pairs. Notice how we lost the squared because the formula requires it to be quantity squared. Okay. We look for the sinc function. It states that, let's put it in blue. It requires 2w sinc 2wt is gonna turn into pi bit pi f over 2w. Okay. Now, how do we turn this into the time domain? Well, we can say this is equal to 2, this is equal to 1/2 2 times sinc 4f, right? Still the same thing. Because these cancel to become 1. We have the f in the numerator already, which is what we want. So this also becomes 1/2 times 2 sinc 4f over 2w, but the w we're gonna let it be equal to 4. No. Need f on top to be, yeah, we let w equal to 4. No?
I don't know. Cause you're trying to get f over 2w?
Yeah, we're trying to get up over 2w.
Yeah.
Is that gonna be?
And now we need Huh?
If you make W four, then it's made up of the two.
Yeah, whatever. Almost got it. My brain's hurting. Okay. So we don't want this two here, actually, we want the four because of this W. It's gonna be 1/2 W. Or 4. Right? I guess it has to be 4. 1/4, 4. 1/8, 8. Shit. Wait a damn minute. Did I do it wrong? Oh, I did do it wrong. I'm so sorry. Let's erase that. Forget that. Forget all this. Okay. The real one says, because I did it backwards. So if it's in the frequency domain, there's a tau sync FT, F tau. That's gonna turn into big pi T/tau. Okay? So we have our F, we have our tau, which is 4. So this is gonna be equal to 1/4 times 4 sync of 4F. Our 4 is gonna be the tau, so now it's in the form of tau sync F tau. You see this right here is in this form. Now this becomes, the 1/4 is gonna stay there. Big pi. T/4 or tau. That's it. So now. We have our xt, we need to square it because the formula says that we need to square it. So the derivative of 1/4 big pi T/4 quantity squared dt is gonna be the answer to our problem. We can draw it out. It's gonna look something like this. I made it look like a triangle, that's very long. It is amplitude of 1/4. Say 1/4. It is defined between negative tau and tau. Right? It's gonna be defined between -4 and 4. It'll be like this, right? That's the shape right here. Let's square it, so I'm guessing this is 1/8, no, 1/16 now, I don't know.
I got -2 and 2.
-2.
Yeah.
Well, let's see.
Because it's tau over 4
Oh,
and the 1/2 shifts.
I have it here. Tau. The formula says this T/tau is defined as 1 when absolute value of tau is less than or equal to tau, not t. Tau over 2, yeah, so it's gonna be 2 and 2, and 0 elsewhere. So yeah, this is gonna be a 2 and 2, -2. Therefore. And the amplitude is still gonna be 1/4. Now, I don't know if we're supposed to square the quarter or square the area. What do you think?
Where the quarter?
It's 1/16 times 4.
Yeah.
So 1/4. Huh?
Nothing, the other one is.
You square the amplitude right here?
Yeah.
Yeah.
So the answer is gonna be 1/4 squared times 4. Is equal to 1. But anybody get it right? No, nobody got it right. I'm in.
I wrote the answer, but I didn't get it. 1/4J,
Row for.
Okay.
So yeah, I need a value.
know where the J came from, but. It's
Damn.
J.
Okay.
Yeah,
Well, I put 2 and I got it wrong.
You told me.
one thing about me. I'm right there. Cause I didn't do this one, I did it in class.
Well, this is the only part I'm stumped, whether you square the amplitude or you square the area. Probably the amplitude. So the answer is gonna be 1/4.
I was over squaring the.
Yeah,
Not
you-
my day.
Amplitude.
Huh?
You're only supposed to square the amplitude.
Yeah, I guess it wouldn't make sense to square the area, cause that'll be a 4th dimensional thing,
Yeah.
right? Any questions on this problem? Let's put a rainbow box around me, yay!
Hey, Rene, when you said spectrum last time, I thought you meant the rainbow spectrum.
You already wanna give up?
Yeah, I gave them a lot. You know, it's
They have electronics.
exactly, I gotta wake up at like 7
We're electronic professor.
Salts.
Oh.
We should go over autocorrelation and noise.
I don't know how to do autocorrelation at all.
I have no idea either, which is why we should go over it.
We're all students.
Autocorrelation.
We just call on the final.
We collectively don't answer it, they'll give us.
Exactly.
You spent like what, 2 days,
Not even.
one day?
One day.
The last lecture was like,
Yeah.
He's
I
like,
guess let's pull up the slides for noise and
the
autocorrelation.
final, I'm like, bro, no one's paying attention.
Like 40%, and he was like, actually 50%.
Screw you guys.
And I just said at first. Maybe on the final, if we do better on the midterms, feel like it's. Rotates our final grade with one of the midterms.
You don't have a number in your email?
Nope, I'm so awesome, aren't I?
Yeah.
Hold on, let me check my grade for senior design.
Yeah, it's already there.
Apparently, according to Dr. Passos,
Who's the baddie in the
Only
corner?
like 2 groups are.
it looks like a mugshot.
We usually
Just
just block it
got
out.
tons of them.
Your stuff being shared.
I'm about to be,
Transporting illegals. on school buses.
And it's a school bus job.
Come on, hurry up. While taking a break to check their next grades. Did that senior. 98% done.
That's the same GPA.
She. Oh, so is Liz's. Liz just told me that it was the same GPA. Where is it? Senior design, 1, grade pending. Crap. He said that it was there. Don't look at my.
maybe in
Be on
Blackboard,
Blackboard.
Oh, I know that. Unless.
Jinx.
Up on,
confidential for your time, all caps.
it's over here.
Yeah, it's not gonna show up on degree works until they turn in the grades, which is next Monday.
It's a 1.
What are you checking exactly?
My grades for senior, it's this one right now, it's up there.
Bro, we didn't turn into possible like
What was
Blackboard wise. Because it is.
it's not gonna be there.
Yeah. Whatever, I already checked the list, that's where it was. Blackboard, oh, already Blackboard. Courses. JSON. JSON. What do you wanna do, autocorrelation or noise?
Both.
Oh, that.
Okay. We're learning this together. Correlation and matching process, autocorrelation refers to matching of the signal with the delay version of itself, the autocorrelation function of a real valued energy signal, that was blah. This is literally the same formula as the,
Superposition.
oh, what's the other one? Convolution. If we look at the formula for convolution. It's the same thing, see? F tau G T minus tau. X tau X T plus tau in this case. So. Symmetrical in tau about 0, maximum value occurs at the origin. Example, a random process with a sample function of blah, find the DC power.
It looks more like frequency translation.
What are we looking at? This thing?
Yeah.
Hmm.
Or time delay.
Looks like a time delay, but it's a product of the original signal times a little time delay.
Yeah, but convolution has neither of those things.
Well, you said it was similar. You literally said it. I can't look at it. What he said
Oh, I see it now.
was autocorrelation, same as convolution? That's what I wrote down.
Yeah,
Let's
I
look at
see it now.
this example. DC power of R infinity. DC power minus DC. I guess we should write down these formulas for the exam. Our spectral density formulas. Those look important. What would my pen on me? Oh, I do have my pen on me. I put my pen on me. There's it. Powers, spectral density functions. Total power. This is that weird one where, like, there's impulses and waves in the same spectrum. It's really weird. Let's look at an example, see what we can do. Random process with sample function blah, where theta is a random variable with uniform distribution, find the DC power. Interesting. Snip, snip. Page. Move this.
Huh?
Oh, it's your icon on my screen, I'm telling you to move. So our NT is this, alright, so theta is a random variable with uniform distribution. If you recall, uniform distribution means that the values could be between negative pi and pi. Right, because after these two values, they become redundant, wouldn't they? Like, there's no point in having a 2 pi. That's just the same as 0. You know? So anything on this side and this side is redundant, so we don't include them. Okay. All we care about is the values between negative pi and pi, and since it's an even distribution, it's gonna look like this. That's the distribution of theta. Find the DC power. Did you work this out?
Yeah.
Oh, okay. Oops. So according to this, in order to find NT, that's gonna be equal to 1/t from 0 to t, a cosine of 2 pi of 0 t plus theta d time. Right, this is, this looks like this is the power formula, isn't it? Oops. This is the power formula. We're looking for DC power. So we use the power formula, makes sense? Yes or no? Yes, of course it makes sense, you're awesome. However, it's a sinusoidal wave. The power. It's a sinusoidal wave like this. What the? Oh, it's because I'm scribbling it. And it thinks I'm like scratching it off. Because when I scratch it like this, it erases it. Ah, genius. Okay. So since it's a sinusoidal wave and this right here cancels out with this and this cancels out with this is gonna be equal to 0. The power of this right here is gonna be equal to 0. However, that's the power of this message signal. However, NT NT being this right here. It's gonna be X F X dx. Where do we get that formula from already? I don't know. X F X dx. Oh, I guess that's the total power formula. Yeah. That was the first formula from the power spectral density functions. AKA this one right here. Right, it's this. So we apply that formula to our NT. And we
The
get,
second one?
huh?
You don't want the second one?
Not yet. We're doing total power apparently. Because in order to find the total power, we have to find the area of this at FZ. So let's just go in order. Okay. Because in order to find the area, we need to find this first, yes. You know. So we substitute our values. The random variable is the theta. This becomes, we don't have to integrate from infinity to positive. Then infinity, positive infinity, we can integrate from pi to negative. Negative pi to pi. Amplitude is ambiguous. Yes, we don't know what the amplitude is. Cosine of Mobius. 2 pi f0 t plus theta. Apparently, the amplitude here is 1/2 pi. I don't know why. Oh, because it's an even, it's a uniform distribution, right? Here. The area of this uniform distribution has to be equal to 1. And if this down here is 2 pi, then the height has to be pi over 2/pi in order for it to be, okay. So the amplitude of this uniform distribution has to be 1/2 pi, and that's where we put it down here. D theta. Why d theta, Renee? Because that's our random variable. Don't ask again. Okay, with many times. We can pull out our a, which is a constant. That's going to be equal to a from negative pi to pi of this is a sum right here. Right? We have to use the cosine sum identity. Cosine of a plus b is going to be equal to cos, sine, change sign. So this is the formula right here. If you have cosine of a plus b, it's going to be minus, and if you have a minus b, it's going to be plus. The way my professor, my teacher in high school taught it to me is cos, sine, change sign. And sine sum, that's what sine sum a plus minus b is sine cos, sine, same sign. All right. So, this is also a constant, isn't it? This 1/2 pi. Yay. I don't know where it went. But it disappeared on my paper. All right. So we have a cosine sum. We write down our identity cosine of 2 pi f0 t times cosine of random theta. It's a sum, so it has to be minus sine of 2 pi f0 t sine of random variable theta. D theta. Boom, chakalaka. Very interesting, isn't it? This is NT. NT. Right? Now. mm, Huh. Lost, but I'm gonna pretend I know what I'm saying. Um, what is NT again? Is NT our total power?
Yeah.
What? Could have been equal to what?
Easier to get this wrong.
I guess, yeah.
So why is it 1/5, not A/2?
It could have been A over 2 pi, I guess.
Sure.
So this is our solution for NT, which is, there we go. Which is, I don't know what it is.
This is the total power formula.
This is for NT, but I don't know what NT is. NT is just this given right here. And then we applied this formula, which is
Looking at the
Oh,
notes
formula.
from looking at the notes from the previous classes, it's saying looking at total power is n squared.
Oh, so we have to
So
split.
yeah, it's like yeah, I can send you a picture right now in the group just so you can see what I have her notes. But
Yeah,
it says total power, or what I wrote down was total power is n squared.
why
N
did
squared
he
T.
this, because I know he wrote this down. I don't know what it's for.
Well, this nt is to find nt squared, I think.
Huh. So
And I
then
think
where it's,
yeah, so I think it's like after we sum it down, we square it or something like that, and then subtract it from something. But let me send a picture in the group chat so y'all know what I'm talking about.
yeah. Yeah, I have a similar image here. Random process with sound function. I guess as long as you write all this down, it'll look a little bit better than nothing. And, huh?
I should be down, it probably gets up there very.
Yeah.
You know what, I know that if I knew what to do with this phone. I would sit here.
Or is it fault or not, so.
That's a big.
Technically, that's
I bet.
kind of a cheat sheet, no? If I just put it on one page.
Yeah. You're not gonna-
Okay, I'm just do that, call it a night.
If I were able to find this online, I would get 8/2 pi. No, 8/2.
This isn't check anything, we're allowed like 5 sheets, so you could just print on the other side of all the sheets, and then the cheat sheets from the back.
Bring the whole mess.
That's exam.
Yeah.
It's chip sanity. Pleasure doing this. This is good.
Those codes, sign. Apparently that goes to 0. Let's go ahead and see. Yeah. Oh. Nice.
Don't put it up.
Yeah, I see, I'm looking at it.
I think it's because, I think the reason why it goes to zero is because, I think we're substituting for theta. So sine of, so basically sine of pi is zero. So that's why that whole thing cancels out, because sine of pi equals zero times the cosine basically makes the whole thing zero, which only leaves the plus sine two pi t f0 t times cosine theta.
If anything, this would be the one that goes to zero, no?
No, well, no, I think you, no, it's because when I scratched it out, the one that I showed you, it's after the integration.
Oh, okay.
Yeah, because we integrate d theta, so then it'd be the cosine theta would change it to sine theta would change it to negative cosine theta, which would leave us with cosine 2 pi ft sine theta plus sine 2 pi f0 t cosine theta, as it's after it's integrated. So then when you said
You wanna integrate by parts?
no,
Damn.
I don't even think we integrated by parts.
How do you even integrate this?
Well, because technically it's because it's cosine. Because it basically all that inside is one term. You can
This right here?
chop it. Well, the full basically the full thing is one term, and there's a addition. There's a subtraction symbol in the middle. So technically, it could be the integration of from negative pi to pi cosine 2 pi ft minus cosine theta minus the integration.
Wait a minute, I see it, I see it, I see it, I see it, I see it. Okay. Whew, right. So we can split this up into 2 pi, anything like that. Let's put a bracket here. From negative pi to pi. Now, it's d theta, that's the secret here. So in reality, we can pull out the cosine right here. Because this is a constant. Minus, this is also a constant. And the integral of sine of theta, like that. Boom.
How much of it?
You see what I did there?
What do you mean, how much of it?
Like how much of the example?
There's no theta here and there's no theta here, so we can pull them out as constants.
I would say like 40.
Now this right here becomes sine, just a sine. So cos 2 pi f0 t
Yeah, it is 40.
sine of
Oh,
theta
mine was 35, sorry.
minus, this is a negative cosine, so it becomes a plus. Sine of 2 pi f0 t cosine of theta. 1/2 pi a evaluated at
You said they were-
from negative pi to pi. Boom. Easy peasy. So, because it's evaluated at pi, the cosine becomes, well, the sine becomes 0. Right? So both of these are gonna be 0, so this is all gonna cancel. All we're left is sine of 2 pi f0 t. Negative pi would be -1, so minus. Minus sine of two pi f zero t cosine of pi is one. On the last,
I'm leaving. I officially give up.
1/2 pi a,
Birthday, Saturday, and just for
it's all right. Later,
like,
this becomes, it's the same term, so it's two. Wait, this is a cosine, where did I put? Sine. Wait, no, I was right.
It's one divided by and then minus the same thing with negative.
Yeah, so cancel out that two, all you're left with is a over pi minus sine of two pi f zero t. That's it. Right? Like me?
No.
Would take that as an answer. If you were to. Like, looks good to me.
Is that what you got over there, Jesus? No, it's not, of course it is.
I got some weird shit. I think it's because Sun always does this. He always just disregards shit. So
Maybe
I ended up with like after the substitution with -1 minus parentheses -1, which equals 0. But I think that's because he basically either factored out or took out altogether the sine 2 pi f t f0 t. Because technically it's
I think you just stopped working on it after this, and just stopped working on it.
Yeah, because
no, because I think we kept working on it because like if you notice in the picture that I sent in the group chat, at the very bottom it says AC power equals a squared over 2 minus 0. The minus 0 is I think the n
Oh,
nt. I think nt is
Thought that was the DC power.
yeah, AC is DC power.
Yeah.
Sorry, NT. I think NT is DC power. And then yeah, NT is DC power. NT squared is total power. And then to find AC power, you subtract total power from DC power.
AC power is the total power minus the DC power.
Yeah, that's what I'm telling you. The sun does some weird shit because I think looking at it from here, I just have basically what you have there equals -1 minus parentheses -1, which equals 0. I think what Sun did is he factored or he just left the cosine theta by itself with the integration. I mean, because that's technically what happens, right? Because the sine 2 pi f naught t, that's technically another constant, so we can take that out too.
it's right here, it was sticking out right here.
No, I'm talking about where the arrow is.
Right here?
No, the one on the right. Because it's sine 2 pi f naught t cosine theta. We're only integrating theta. So technically the sine, all that is still a constant, so we can take that out again.
Huh,
Because technically, because then technically it'd be, I think cosine of negative pi or cosine of because it's cosine then it'd be yeah, because it's then it'd be cosine of negative pi minus I don't know. I got some weird stuff here.
well, I don't know how we got that, but I got this.
I like this.
Yeah, I don't know. I was following Sun and I don't know.
Something work this one out.
I'm saying, he just told us that it's -1 minus 1, or,
Negative pi is all he, I'm sure it's big. This is the one he did. And then he moved on.
yeah, he was very quickly. Let's put a pin on it. That's a pin. And then get to the n squared t.
Oh, I remember why now. I just figured it out.
Whatever.
So technically, cosine of negative pi is still cosine of pi,
Right,
right?
well,
So technically, yeah, because
yeah,
pi is negative pi, so technically, so it'd be cosine of pi minus cosine of negative pi, which are both -1. So it's
oh,
-1 minus
negative.
-1, which is 0.
Yeah, you're right. I see it. So that's 0. Okay, now for the square, now for this part. We have our a squared, we have a cosine squared, and we have a bunch of garbage. If you recall, it's a sinusoidal. So it's gonna be 1/2 a squared, that's it. Just because you're looking for the power of a sinusoidal, it's always gonna be 1/2 amplitude squared. Always. Okay? If it was a triangular, it would be a third, if it was a square, it would be a whole. So you don't have to work this out at all. All you gotta do is remember that power of a sinusoidal is 1/2 the amplitude squared. That is the AC power.
DC.
Total power. N squared is total power.
This total power?
Yes, or I'm looking at Sun's note, that's total power.
Okay.
Then
Stupid. How do I hide you? Total power. Alright, now we have our DC power and our total power. Our AC power is gonna be. Sorry, this is our total power. 1/2 a squared total. Minus 0, which is our DC power, equals AC power, which is gonna be a squared. Those are the 3 values that we're interested in here for this particular problem. Right,
Does the DC count as power and the total power?
yes, but there is no DC power in this case. It makes sense, because if you look at this right here, it's a sinusoidal. Sure, there's a component here that's that changes the phase, but it's evenly distributed, so the average is 0. So there is no DC component to this signal right here. So there's a 0 DC, there's a total power, and then there's the AC power. All the powers come from AC apparently. Man, that was tough. That right there, we spent the whole hour of the test on 1 question. I think
We're
Aaron.
gonna,
Huh?
we're gonna have like 2 hours for the final this time, like an hour and 5 minutes, because I saw that it was from 10:45 or I think 10:15 to 12. So do we have an hour 45 for it?
Let me check the schedule. The last time I checked it, I sent it to Eddie. Let's see. We have from 10:15 to noon. That's an hour 45.
Because Damien's he's gonna add more questions, or what do you keep to say?
He's gonna throw shit under that we've never seen before.
Straight up, dude.
Any more questions on the exams or the finals? Exams or finals, exams or quizzes? Bunch of chocolate here. We can do ACE, we can do AM modulation, FM modulation, phase modulation, pulse code modulation. Um. Delta modulation, what do y'all wanna do?
Do you think he'll
Everyone-
ask about delta modulation?
I don't think so, that was a homework, right? They didn't put it on in the list.
He did.
He didn't, he did.
Thought he only put AM, FM, and phase.
Oh,
I don't see no delta, you liar.
I'm asking, what do y'all wanna hear about?
Oh,
AM, FM, phase, wide, narrow,
I'm still not too confident on phase.
phase modulation. That was in the quiz, that was an exam too, right?
Yeah, I feel like I know literally nothing about it. I know the process is kind of the same as frequency, but I could be wrong.
Alright, let's do that one. But let's do an example from the textbook. That way we can have a different values. How do we do this? Do I have the textbook on my phone?
What were you trying to do?
Phase modulation.
Is that on the exam?
It was, but we already did it on the other review, so I wanna try to get another. What's the word? The bird. Yes, the bird. I was gonna try to get another, oh, I have it on my Google Docs. I was gonna try to get another problem. So that. It's just not writing the same thing over and over again. What am I gonna password? My. Comparing. And it. What's another one drive? Time. What in the heck? Where is it? Here, no, it's gotta be here then. Documents. No. No. Here's your moment, no. Spring break 2010. Damn. Ugh. Where the heck did I put the textbook? This can just pull out my laptop. Forget to like, share, subscribe, and leave a comment down below.
For the channel.
It would help a lot. And according to YouTube statistics, most of the people that watch my video are not subscribed. Okay, I know I have it on my laptop. I just don't have battery in it. the flux messaging. Oh. Well, oh, that's what we just did. Right. Um. Textbook, textbook, textbook. We'll be right back. Oh, thanks in chat. Come on, buddy. You got this.
Yeah, I remember how many like random process examples he's gonna put on the final or no? Because I have in my notes that for sure 7.1, the one that we just did, is gonna be on the final. Because I think he said like this will be on the final. And then I also have problem 7.14, but it's like a similar problem will be on the final.
Everyone's so quiet.
Yeah. I guess I'll just do it over. Okay.
Are we stressed?
Huh?
Are we stressed?
Yeah. Okay. This is exam 2, number 4. Oh, man, how fun. For the message signal, MT equals 2UT. And unmodulated carrier cosine of omega CT. A, draw the output of the phase modulator with MT. Pretty simple stuff, right? Letter A says draw the message signal, very simple, it's a line. The amplitude is 2. And that's your message signal right here. Yay. Now you have to draw the output of the phase modulator. Okay, did you get that? Yeah. Okay. For B, you have to get the output of the phase modulator with MT KP is equal to pi over 2. Okay, PT, this formula says that if PT equals KP over MT. We know our KP, pi over 2. So, this is equal to pi over 2 times the message signal, which is 2 UT. 2's cancel, you're left with pi UT. Pretty cool, right? So this is your BT, all right? So according to the formula is where's it? I think I wrote it down for something. This is for phase modulator. Phase modulator. XCMT is equal to A cosine or AC cosine of 2 pi FCT plus KPMT. Okay, this KPMT is this right here. Okay. Let's do it in purple. Purple. That's where we got this from. So now we have to redraw it as A cosine of 2 pi FCT plus pi UT. What does this mean, Renee? What does this mean? It means that when t is equal to 0 and beyond, you're gonna add a phase of pi. So our signal is gonna be like normal, right? Actually, start over here. Our signal is gonna be normal with an amplitude of A. But as soon as we hit t is equal to 0, we're gonna add a phase of pi. It's gonna look like this. And that's the output of the phase modulator.
So why is it only when it hits 0?
Because that's what the UT means.
Okay.
UT is this right here,
Yeah, the square looking one.
something like that. It's called units impulse function. I don't know.
Have the output of the signal, if U of T was 1. You wanna try that?
If UT was 1,
Yeah, I don't know, because you're looking for it in the book, right? I have that drawn down.
let me see it. Okay. I mean, we already started this one. Oh. Yeah, a little bit different. Make a little more chic.
Same.
Oh, shit.
Just if, right here. Missing. If U of T was 1,
Oh, cool.
it's from,
Yeah, which is good. We're like fraction of pi, yeah.
I don't know if you wanna do that.
Okay. Okay. Any questions on this phase modulation? No? All right,
No.
let's do C real quick. The message signal unmodulated carrier. WC equals 25, draw the output of the frequency modulator. FD equals 10. All right. The formula says. What was it? For frequency modulation. It is XCM, okay. XCMT is equal to AC cosine of 2 pi FCT plus 2 pi FD integral M alpha D alpha plus this. What? What do you mean, Renee? Well, this FD right here was given to us by the problem FD equals 10. Pretty sweet. So we have to calculate the integral of our message signal. Our message signal looks like this. How do we calculate the area for this? You know what I
Is
mean?
this from test 2?
It is just 2, huh?
No, I'm saying, is it from test 2? I'm not saying it is.
Oh yeah, this is test 2.
Okay.
Sorry.
That's fine.
Okay. Um. I'll put the alpha. Well, this right here would be AC cosine of. Oh, it tells us that omega c in the problem, it tells us omega c is equal to 20 pi. So this right here is 20 pi. Cosine of 20 pi t plus 2 pi times 10 times this integral, which I believe the integral is just a 2. Like the answer is 2t. No? I think so. Plus this phase shift, which I don't think we need to use it here. This becomes 40 pi 40t, 40 pi t. This is 20 pi t. Plus that becomes AC cosine of 60 pi t. So the output of this phase modulator is that it starts off like this. With a frequency of 10 hertz. Before, it starts at 10 hertz. And then afterwards, it shifts into overdrive and it goes to like 60 hertz. Mother clucker. Don't erase. Okay. 60 hertz.
Just here, there.
Shift 30. Now you don't. 30 hertz, sorry. So that's the output of the phase, the frequency modulator.
Is that it for phase modulation?
That's the whole thing that I have from the exam too. Yeah.
Because is like, for example, finding the amplitude spectrum and phase spectrum for phase, how would we do that?
I don't think we can.
Yeah, I don't think for phase modulation it says to find the amplitude spectrum.
I don't think it makes sense to do it in this situation.
It doesn't show it in the test 2 that to find the amplitude modulation or the.
Who's here? Let's see. We're down to
Thinking
4.
Professor,
Huh?
staying in attendance, Professor.
Oh yes, I'm taking attendance.
Here,
Here.
Pacheco?
Here.
Okay.
Do we get extra credit for being, do we get extra credit for perfect attendance?
I don't know, you
The
weren't here
10% of our grade.
Extra 5 points?
It is gonna
Mr.
be, on
Final?
your- attendance is gonna be on your exam,
Give me part exam?
yeah.
How many days have you showed up? It's either all or none.
Any more questions, any more insecurities?
There's so many, Rene. So many.
I'm insecure about the test.
Yeah, I think we all are.
I'm having an existential crisis.
Ooh, I've got one.
What's up?
Test 2, problem 1C. I know you sent how you got the filter power, but how did you get the filter output power?
Oh. Okay. Ah. Test 2 filter output power. I got it wrong because he told me to show my work. When this is test 2. Number 1. I guess C.
That you cheated that's why.
I did not cheat.
Well, you didn't show your work.
Well, my work is down here. Anyway. We know how much power is at the inputs. You see it's a FM modulator. And then it goes into a low pass filter.
It says bandpass filter.
Damn, sorry. Band pass filter. Okay, and then output. We have the output right here is equal to 10 sine of 200 pi t plus this thing. It's a horrible plus. Plus that. We know automatically what the power for this is gonna be. It's gonna be 1/2 10 squared, which is equal to 50 watts, right? So there's 50 watts going into this bandpass filter. And how many watts are coming out of it? Well, the bandpass filter, the question says, has a center frequency at 100 hertz and a bandwidth of 50 hertz. That means that when you draw out the diagram, the spectrum, it's gonna spread out between 75 and 125 like this. It's gonna be your filter. It has a center frequency of 100 and it's gonna have a width of 50 hertz. Okay, does that make sense so far?
Yes.
So what impulses are gonna be in here in order to, which frequencies are gonna pass through this bandpass filter? We have to go to our Bessel table. And at 100 hertz, it's gonna be 7.65. At 110, it's gonna be 4.4. At 120 is gonna be 1.15. It's gonna be mirrored. I see Eddie tuned out already. Okay, so the bandpass filter is gonna encompass these 5 impulses, these 5 frequencies. There are more values here, but they're gonna be cut off by the bandpass filter. So what's the power in here in this bandpass filter? it's gonna be 7.65 squared plus 2 times 4.4 squared plus 2 times 1.15 squared. All that divided by 2. It's gonna be equal to 49.94 watts.
That what you put down on your set?
Yes, but I have to show my work.
You said,
Huh?
you said mine didn't add up to that. That's, it does add up.
It's weird. Yeah. Is that what you put?
You
Maybe the
try to do it in this.
10. Did you put 2 times 7.65 by accident?
No, no,
No. You square them?
just like you wrote it up there, I wrote it down.
Exactly, wow. What a jerk. Well, yeah,
That 2.2 times.
oh, it's because there's 2 4.4s and there's 2 1.15s. You use the vessel chart when you have a beta value that is not much less than 1. That means it's a wide band signal.
Are we gonna go over noise?
I don't know what to tell you about noise. It's part of the curve. See noise, let's see what's in here.
Let's see, put some of this on multiple choice, what you want there. There was one with a filter down below that he pointed out.
Oh yeah, he's gonna add that one, right?
Yeah,
This one,
it's like, I'm gonna teach you something new, and it's gonna be on your final exam.
That,
Yeah, that one. It was that one.
noise equivalent of bandwidth. A simple RC Lopez filter shown in the figure below. Find the noise equivalent bandwidth, B equals is equal to the transfer function squared from 0 to infinity. So I have to find the transfer function for this. And then get that in the integral. Holy shit,
the solution is.
okay, so. We use a voltage divider here. To get this. I guess we don't want, what's it called? Complex numbers at the bottom. We're left with this right here. Omega CR. I would just write all of this down on the cheat sheet. To be honest. Like just this entire 2 slides. Write them down on the cheat sheet. This is just a general solution. It's not even using these values. It's pretty cool.
And it doesn't even finish the question. It
Yeah,
does one part of
the-
3 parts.
Yeah, the 3 dB.
Yeah, it doesn't find the 3 dB or the error either. So I don't know what it's gonna ask for because we didn't go over that.
Space.
Simple. Equivalent bandwidth.
I'm just saying, but out of solidarity, if we all get zeros on the final,
You can't
he
zero
has
out.
to he has to just disregard the final. Am I wrong?
Well, yeah, but if you did horrible on one of the first exams, you're gonna want a good grade on the final.
I'm doing fine in both exams. I'm good.
He's gonna combine with Bengalia and then he's gonna stick with the zeros.
plus 30.
It's gonna be plus 30.
Yeah, it's gonna be 30-point curve.
Yeah, 70, yeah. That's the goal.
More like a 40. You get a 70.
Jeez, I'll take that too.
Is no one looking at me?
Jesus Christ. Somebody take a screenshot. Somebody take a screenshot.
O ver las espinillas, carnal.
Sí, ¿verdad? Y bien, compadres, ¿qué más les cuento?
Introducing that as the camera.
Professor Rene,
Pointing at me, yeah, what's up, what is it, sir?
how do I get a girl?
You walk up to her and you press A.
ChatGPT.
What is this, Skyrim? What is this, Skyrim?
Any more questions?
I still have another page of formula sheets that I haven't filled out.
So it's what's the formation that we are allowed?
Oh, we are allowed
I think it's the one from test 1, test 2, and then the one you make for the final, the comprehensive.
we are also allowed, oh, let me write it down in the chat, so I don't have to say it 1,000 times.
That's good.
We are allowed, 3 cheat sheets.
I mean, I'm doing all of them from scratch.
One per test. We're allowed integration sheet, integration chart. This is optional. We're allowed the Fourier pairs. Fourier table, Fourier pair table. Trigonometric identities. Bessel table. ¿Qué más? That's it.
It's a small little booklet that we can take.
I can print some out the day of.
The day out.
Yeah, I can get here early and just print out a few copies because we need them.
You guys think it's gonna be kind of similar to the other tests? Or no.
Probably. And by that I mean, he's not gonna have any of the multiple choice questions we've had in the past.
I don't know that.
He's like, I changed the test a little, and then it's like a billion different.
No, it's just confusing. That's not even gonna put them all back.
Well, I'll stay here working on my formula sheets. Y'all wanna stay on Zoom? I'll stop recording.
Yes, we'll keep you company.
Aw, you're so sweet. Stop recording, where's the stop recording?
And then check the group chat real quick.